Students of ninth standard, we are discussing about 11th unit atomic structure, subatomic particles, electronic configuration, geometrical representation of atomic structure of elements we learned in the previous sections. Now next we are going to study about valence electron. And before that, we have to recapitulate what we have learned already. The discovery of nucleus. This was done by Lord Rutherford, a scientist from New Zealand, bombarding a thin gold foil with a very small partially charged particle called alpha particles. And from that, he observed and concluded the atomic model. The atom contains large empty space. There is partially charged mass at the center. Size of the nucleus is very small compared to the size of the atom. Electrons revolve around the nucleus. The circular paths are called orbit. These things were submitted by Rutherford by his gold foil experiment. And next, Bohr's model of atom. According to Bohr's model, when electrons revolve around the nucleus, they neither lose energy nor gain energy, but only when they are going to move from higher level to lower level or lower level to higher level, they absorb or lose energy. And the energy shells are represented using the letters K, L, M, N. Also numbers are used. N is equal to 1, 2, 3, 4 from the nucleus. Then we have learned about the discovery of neutron, which was done by James Chadwick in 1932 using alpha particle bombarding the beryllium. He found a neutral particle, a charged particle is emitted, that is called a neutron. In characteristics of fundamental particles, there are three fundamental particles that already you learn: electron, proton and neutrons. Electron is negatively charged particle, proton is positively charged and neutron is neutral particle. Then nucleus or nucleons. The nucleons are nothing but the protons and neutrons are normally collectively called, the sum of protons and neutrons are called nucleons. And the circular path in which electrons revolve around the nucleus is called orbit. Also we learned about atomic number. Atomic number is nothing but that is the total number of protons present in the nucleus of an atom, which is always equal to the total number of electrons which revolve around the nucleus. So atomic number Z is equal to number of protons, it is also equal to number of electrons. Then next, mass number is nothing but that is the sum of proton and neutron in the nucleus. That is the sum of nucleons. Proton plus neutron is equal to mass number. So in the representation, we are going to represent the atomic number in the subscript and mass number in the superscript. Then next we learn about how to find out the number of neutron. The number of neutron formula N is equal to A minus Z. N is neutron, A is mass number, Z is atomic number. When we separate atomic number from mass number, the total number of neutron in the nucleus can be obtained. Next, electronic configuration. Electronic configuration is nothing but that is the arrangement of electrons in the different atomic orbitals. The arrangement of electrons in different atomic orbitals or distribution of electrons in the different shells which is called electronic configuration. And there is a formula to calculate 2n squared, where n is a serial number of the shell from the nucleus. And from the nucleus we start to locate the electron. First shell can have maximum 2 electrons. Second shell, L shell, can have 8 electrons. Then M shell can have maximum of 18 electrons. N shell 32, next 50 electrons, 72 electrons, like that. Using the 2n squared formula, we can locate the electrons in the different atomic orbitals. Then how to geometrically represent the atomic structure? See, first you have to draw a small circle, that going to represent the nucleus. Inside the nucleus, the nucleons are there, proton and neutrons are there. Inside the nucleus, proton and neutrons are there. Around the nucleus, depend upon the number of electrons, we have to draw the circle. Suppose 5 electrons means we have to draw only 2 circles, because first circle, the first orbit can have maximum 2 electrons. Second circle can have maximum 8 electrons. So we can locate the remaining 3 electrons like that. Then next we are going to study about valence electron. So what is called a valence electron? That is nothing but the electron present in the outermost shell of an atom. The outermost shell. So there is a definition like statement. This para, see, second last para. The outermost shell of an atom is called valence shell, and the electron present in the valence shell is known as valence electron. So the last orbit in the particular atom, the last orbit is called valence shell. The electron present in that shell is called valence electron. And the chemical properties elements are decided by these valence electron, and since they are ones that take part in chemical reaction. So the valency is decided by the valence electron, because these valence electrons only take part in the chemical reaction. That is, the electron present in the outermost shell of an atom take part in the chemical reaction. Then the elements with the same number of electrons in the valence shell show similar properties. Those with a different number of valence electrons, different chemical properties. For example, see, the valence electrons 1 or 2 or 3, except hydrogen, this 1, 2 or 3 may be in the outermost shell orbits of the metals. Metals going to have 1 electron in the outermost shell, or 2 electron, or 3. For example, if you take sodium outermost shell possesses only 1 electron, sodium. And similarly, see, when you are going to take potassium and aluminium going to have 3 electron in the outermost shell. Aluminum going to have 3 electron. Magnesium going to have 2 electron. So metals going to have 1 or 2 or 3 electron in the outermost shell. And normally non-metals going to have 4 to 7 electron in the valence shell. Carbon 4 electron in the valence shell. And similarly, see that chlorine going to have 7 electron in the outermost shell. So depends upon the number of electron, we are going to locate the electrons in the orbits or energy level. Next, what is called valency. We already learned in the 8th standard, valency is nothing but that is simply a combining capacity of the atom of element. Valency of an element is combining capacity. So how many electrons take part in the chemical reaction, that going to decide the valency. That's why they are taking part of the electron only from the outermost shell of an atom. Outermost shell from the valence electron. So valence electrons only take part in the chemical reaction. So how many electrons are taking part in the chemical reaction is termed as valency. See, normally valence electrons of 1, 2, 3, 4 is going to have valency 1, 2, 3, 4. Suppose valence electron 1 in the outermost shell means valence is 1. 2 means valence is 2. 3 electron in the outermost shell means valence is 3. 4 electron in the valence electron means that is valence is 4. But in case of elements having 5, 6, 7 valence electron, that we have to separate these 5, 6, 7 from the 8. From the octet structure. 8 is octet structure, that going to give a stable configuration. So 5 electron in the outermost shell, that means a valence electron 5 means that we have to separate 8 minus 5, 3. That 3 is the valency. Then 6 electron, valence electron means 8 minus 6, so valency is 2. 7 electron valence electron means 8 minus 7, valence is 1. Valence is 1. Next, see here, then 8 is the normally the number of electron required of any atom to attain the stable electronic configuration that already learned. That is called the octet structure. Rule of 8. Rule of 8 means the tendency of an atom having 8 electron in the outermost shell. The tendency of an atom having 8 electron in the outermost shell. Normally, the noble gases, rare gases, inert gases, the last column of the periodic table, these elements except helium possess 8 electron outermost shell. That's why they are called inert gases. When an atom going to have 8 electron, they are in stable structure, and also they are in the inactive in nature. Inactive in nature. So elements helium, neon, argon, their outermost shells are completely filled. So what is their valency? Their valency is equal to 0. Valency is equal to 0. So they will not ready to render any electron or gain an electron. They will not take part in the chemical reaction. So the electronic configuration of neon is 2, 8. That second orbit is completely filled. So the valency is 0. Similarly, you can find the valency of magnesium. You can find the valency of magnesium and sulfur. You take your notebook and write what is the symbol of magnesium. Magnesium symbol Mg. Magnesium symbol Mg. And the atomic number of magnesium 12. Atomic number of magnesium 12. So you have to write atomic number means total number of proton or total number of electron. So magnesium atomic number 12, you have to distribute this 12 electron in the energy levels K, L, M. So first shell can have maximum 2 electron. So 2, then second shell 8, 8, then the remaining in the next shell. So 2, 8, 2. That is the distribution of electron. Distribution of electron. Distribution of electron. So the valency of magnesium is 2. Valency of magnesium is 2. Similarly, take sulfur. Sulfur. So magnesium is a metal and sulfur is non-metal. And what is the atomic number of sulfur? Sulfur. What is the symbol of sulfur? S. You got right? Yes. As subscript, you got right. The atomic number, that is 16. 16. So 16 electrons are there. You have to distribute the 16 electrons using the 2 and skate formula. So 2, 8, 6. This is the distribution of electron in the atomic orbital. 2, 8, 6. One electron in the outermost shell, that is 6 electron. 6 electron. So you have to subtract 6 from 8. 6 from 8. So you will get 2. So valency is 2. Valency is 2. Then normally the atoms going to have electron 1, 2, 3. These atoms are ready to donate the electron. Ready to donate the electron. They are electropositive in nature. Electropositive in nature. Normally metals. Suppose the atom is going to have 5, 6, 7. 5, 6, 7 electron in the outermost shell. Valence electrons are 5, 6, 7. Means they are ready to gain electron. They are ready to gain electron during the chemical reaction. So they are electronegative character. Electronegative in nature. Electronegative means the tendency of gaining electron. Electropositivity means the tendency of losing electron. So normally metals donate electron, non-metals gain electron. Non-metals gain electron. Also see one more activity is given. You can do the activity. So you always keep your rough notebook by the side and write. Assign the valency of phosphorus, chlorine, silicon, argon. Assign the valency of phosphorus, chlorine, silicon. So to know the atomic number, you can refer the periodic table, or the table 11.2 is given here. In the 11.2 it is given, see the first column name of the element, second column symbol, next see number of proton, that is the atomic number. Next column mass number A, that means a proton plus neutron. Next column neutron, that is a minus Z, that is a mass number minus atomic number. Next is the distribution is given. Distribution is given. So listen. Now see valency of phosphorus. Phosphorus, what is the symbol of phosphorus? P. P, capital letter P. Then you have to write the atomic number as subscript 15. Phosphorus atomic number 15. 15. So atomic number 15 means proton 15, electron 15. Proton 15, electron. These two are always equal to one another. Then you have to distribute this 15 electron in the different shell. First shell you have to K shell, then L, then M, like that you have to go. So K shell can have maximum 2 electron. Next shell can have 8, 2 plus 8, 10 electron, remaining 5 electron in the next shell. So K shell 2 electron, L shell 8 electron, M shell 5 electron, M shell 5 electron. So what is the valency? What is the valency of phosphorus? So valency of phosphorus can be calculated by subtracting 5 from 8. 8 minus 5, that is equal to 3. Valency of phosphorus is 3. Next see chlorine. What is the symbol of chlorine? Cl. C capital, L small letter, Cl, and its atomic number 17. Atomic number 17. 17, that means number of protons 17, number of electrons 17. So you have to distribute this 17 electron in different atomic orbital using the formula 2n square. So first shell can have 2, second shell can have maximum 8, then the remaining electron. Remaining how many electron? 7 electron. 7 electron in the third shell, in the M shell. In the M shell, 7 electrons. So 2, 8, 7. So during the chemical reaction, the chlorine going to gain 1 electron. So how many electrons are gained? 1 electron. So 8 minus 7 is equal to 1. It gain 1 electron. It is electron negative in nature. So the valence is 1. Chlorine valence is 1. Next is silicon. Silicon, what is the symbol? Si. Capital S, small I. Si, silicon. And atomic number 14. Atomic number 14. So 14 electrons are there. You have to distribute this 14 electron using the 2n squared formula. So 2, 8, 4. 2, 8, 4. Valence is 4. An atom possessing 4 electron, the outermost shell will not donate or accept electron, will not donate and accept electron, going to share electron, Then argon. What is the symbol of argon? Ar, capital A, small r, Ar. And atomic number 18. Atomic number 18. At subscript you have to write atomic number 18. So you have to distribute this 18 electron in the different shell, K shell, L shell, M shell. K shell 2 electron, L shell 8 electron, M shell 8 electron, 2, 8, 8. So the outermost shell possessing 8 electron means that atom is stable in nature. It attains stability. So those atoms will not take part in chemical reaction by donating or gaining electron. So their valence is 0. Valency 0. So you can refer this tabular column for your practice. Say hydrogen atomic number 1. Hydrogen atomic number 1. And see mass number also 1. So I will get the number of neutron n is equal to A minus Z, that is 1 minus 1, 0. So only 1 electron in the first shell. Then helium 2 electron, atomic number 2, mass number 4 because it possesses 2 proton. So the 2 electrons is going to be located in the first shell. Similarly, the electrons are located using the formula 2n squared. Then here see some the geometrical representation of atoms given. You have to go through draw and practice. See how to draw this geometrical representation of electron, distributing electron. See, the first you have to draw a small circle, the inner circle that represents the nucleus of an atom. Nucleus of an atom. So what are the particles in the nucleus of an atom? Proton and neutron. Proton and neutron. So you have to mention the number of proton and number of neutron in the nucleus. That is given here in the form of dark color. The dark color is nucleus that constitute proton and neutron. So hydrogen only one proton, there is no neutron, so only proton is mentioned there. Then one electron is there, so you have to draw one circle. Depends upon the number of electron, you have to draw the circle. Before that you have to write configuration. You have to distribute the electron in the different atomic orbital using the 2n squared formula. According to that only you have to draw the circle, that means the orbit. The orbits are going to be drawn based on the electronic configuration. You can see the helium. Helium, atomic number 2, mass number 4. So atomic number 2, mass number 4. So 2 proton, 4 minus 2, 2 neutron. So they should be in the nucleus of an atom. 2 proton, 2 neutron, and 2 electron. The same number of proton will be the number of electron. So 2 proton, 2 electron. 2 electrons are going to be located in the first shell, K shell. So only one circle orbit you have to draw and locate the electron. You see the red colored dots are representing the electron. Then lithium, atomic number 3, mass number 7. So that is the number of proton. Here it is given 4 proton, that is wrong. That is 3 proton only be there. 3 proton and 7 minus 3, 4 neutron. 7 minus 3, 4 neutron. So 3 proton, 3 electrons are there. So you have to distribute these 3 electrons in the atomic orbital using the formula 2n squared. 2, 1. Valence is 1. Similarly, beryllium. So many some examples are given up to calcium. We take calcium. Calcium, atomic number 20, mass number 40, symbol Ce. See, 20, atomic number 20 means proton 20, electron 20. Proton 20, electron 20. So 20 electrons are to be located in the different atomic orbital using the 2n squared formula. So configuration 2, 8, 8, 2. 2, 8, 8, 2. So 4 orbits you have to draw. First orbit you have to put 2 dots, 2 electron. Second orbit 8 electron. Third orbit 8 electron. The last valence shell 2 electron. Similarly, you can take that is chlorine. Chlorine 1735, atomic number 17, mass number 35. So 17 proton and the neutron 35 minus 17, 18. So 17 electrons will be there. These 17 electrons are going to be located using the formula 2n square, configuration 2, 8, 7. So you have to practice all these geometrical representation of first 20 elements. Hydrogen, helium, lithium to up to calcium, up to chlorine, argon, potassium and calcium. You have to draw and practice. From this 1 or 2 will be asked in the exam. They are asked to draw the geometrical representation of atomic structure of sodium or magnesium. First you have to write the electronic configuration, then you have to draw the nucleus, and depend upon the electronic configuration you have to draw the orbits and locate the electron. Next, see isotopes, isobars and isotones. Isobars and isotones. So isotopes are nothing but they are the atoms of same element having same atomic number but different mass number. And isobars are nothing but they are having, that is atoms of different element, atoms of different element, and having same number of same mass number, different atomic number. Then next one, see isotones, they're totally entirely different, that is a different element, different atomic number, different mass number, only the number of neutron only same, so we will discuss about this isotopes, isobar and isotones in detail in the next class. So you have to go through up to this geometrical representation of atom for the first 20 element. And previous lesson, I think already finished, and classwork written. Get ready with the classwork and prepare well. And the first lesson, you will be given one test, objective test. Get ready for the test. And this lesson also, after finish, learn thoroughly. Don't waste the time. Thank you. God bless you.